Hey guys, this lesson is about factoring polynomials. So far we've learned about 3 different kinds of factoring. We learned about factoring out the greatest common factor. We learned about the difference of 2 squares, which was like 4x squared minus 9, and that factors as 2x plus 3 times 2x minus 3. Alright, so that was like a second thing. And then we learned how to factor trinomials like this. And they factored as a binomial times a binomial, similar to the difference of 2 squares, but it was a little more complicated. So this lesson is going to involve all 3 things: GCF, difference of squares, and just general factoring of trinomials. But remember, what is the first step of factoring for all problems? That's right, GCF first, guys. So looking at problem number 1, hopefully you recognize that the greatest common factor is 3x squared. For the variables, you always go with the lesser amount. That's how I knew it would be x squared. Okay? And then we can think about what's going to go on the inside of the parentheses. And remember that really I am dividing by my GCF. So I'm dividing by 3x squared. So the 3's cancel, and that's going to leave x minus 9 divided by 3 is 3. And the x squares cancel out. And that's it. So this would be the answer to number 1 right here. Can't go any further than that. GCF. Looking at problem number 2, remember to GCF first, greatest common factor first. Now, 2 goes evenly into all of these. In fact, that is the greatest common factor. I was thinking maybe 3, but 3 doesn't go into 10. So the GCF is 2, but how many x's will I pull out, you guys? All right, the GCF is 2x squared. Always go with the lesser amount of the variable. Okay, make a nice big parentheses. We divide by our GCF when we do this. So I'm dividing by 2x squared, like so. 12 divided by 2 is 6. These cancel and make x squared. 10 divided by 2 is 5. These cancel and make x. 6 divided by 2 is 3, and these x's cancel out completely. So I have this. Now, this red trinomial looks like it might be factorable further. So I must try, because we have factored things that look similar to this before. So as I continue, and I don't just stop here, so I have 2x squared. And then I'm going to go ahead and try to factor this red stuff down. So my thought process is, first I start with the 6x squared and ask myself what times what. Now please understand that 6 could be 2 times 3, so 2x times 3x. Or it could be 1x times 6x, or x times 6x. I usually start with the smaller numbers first, so I'm going to start with 2x times 3x and see how that goes for me. Okay, so how do I know this is the right one? I don't know yet. If it works out, great. If it doesn't, I'll go back and try the other way. But next, I skip over this and I focus on the 3. Now 3 can only be one way. It's 1 times 3. Okay, now it matters whether I put the 3 here and the 1 here, or if I put the 1 here and the 3 here. Now look, I know that the 3 will not go here without even thinking about it very hard, because I know that you should never have a common factor inside of the parentheses. Look, if there was no common factor on the previous step, there should be no common factor suddenly now. Okay, so I know that the 3 won't go here. So instead, I will put the 3 with the 2. Okay, and I'll try the 1 here. Now the key is inner plus outer equals middle. All right, that's the keys to the kingdom. That's the whole ball game. So inner, I'm talking about multiplying these. So that's 9x. Okay. Outer, that's 2x. I'm trying to get 5x out of this. Is there any way to get 5x out of 9 and 2? No, I could get 7, but not 5. Okay, so that means this is not working for me. Okay, which means if it's going to be factorable at all, it must be the other way. It must not be the 2x and the 3x. It must be like 6x and x, the second option. Okay, once again, I know not to put the 3 here because that would cause a GCF, and that should not happen. So I won't waste my time on that. It would have to be the 1 here and the 3 here. Okay, it looks, this is not working either. Okay, inner I have 1x, outer I have 18x. Okay, there's no way to get 5 out of that. So this is seeming to be unfactorable. We must be done on the previous step because this read, we had to try because it might have been factorable, but we tried all of the possibilities and nothing worked. Okay, which means this is the correct answer. Number 3. You're so easy. It's almost insulting to me. We see the trinomial. We look for the GCF. There's no GCF, so we go to the binomial. I'm calling it easy because of the way there's no number here. The leading coefficient is 1. Those are easy. Because we know it'll just be x times x, we look at this 20, and we're thinking maybe it's 4 times 5, or it could be 2 times 10, or it could be 1 times 20. Now, keeping an eye on the 9, which we can do because there's no leading coefficient, I'm liking the 4 and 5. Okay, we only look for the middle term immediately if there's no leading coefficient. So, inner we have 4x, outer we have 5x. We want to get a middle of 9x. That can easily happen if both of these are positive. Kabam! And a positive times a positive does give us positive 20, which means this is in fact the answer. Oh, look, another easy one. Love it. I'm loving it. X squared can only be x times x. 30 might be, let's see, 5 times 6. Okay, or it could be 3 times 10. I'm trying to see if there's anything else in between. 3 times 10. Or it could be 2 times 15. Or it could be 1 times 30. So you have 4 options to make 30. But again, because there's no number in front, we can immediately look for the 7. Ding, ding, ding. I'm seeing a 7 right here. Okay, 10 minus 3 is 7. Okay, so I'm going to go with the 3 and 10 option. Now, inner plus outer equals middle. If I want a positive 7, I'm going to need a positive 10 and a negative 3 to make positive 7 middle. So there's my negative 3 and there's my positive 10. Does that give me negative 30? Let's see. Negative times a positive is a negative. Yes, sir. So this is the answer to number 4. Why is number 5 so short? The middle term seems to be missing. There's no GCF. How in the world will I factor this? Oh yeah, this is the difference of 2 squares. All right, I know 49 is a perfect square because I know it's 7 times 7. And of course, x squared is x times x. So the difference of 2 squares always factors as something plus something and something minus something. So this will be x plus 7 times x minus 7. Okay? And this works in the traditional way. If you understand that all this is the same thing as x squared plus 0x minus 49. Okay? It's just that the middle term is 0. Okay? So it still works like all the other problems we've been doing, but x squared is x times x, 49 is 7 times 7, and if we have an inner of 7x and an outer of 7x, well, if I want the middle to be 0, I need a plus and a minus to make that happen. And so that's what I did. All right, but this is so common that it's worth just memorizing x plus 7, x minus 7. Okay, looking at number 6. Okay, back to the easy trinomial problems. X squared can only be x times x. Now 24. This could be, let's say, 4 times 6, or it could be 3 times 8, or it could be 2 times 12, or it could be 1 times 24. So again, we have 4 possibilities. Again, because the leading coefficient is 1, we can look immediately for the 10. Okay, so I see 2 options, 2 possibilities. All right, 4 and 6, if I add them, I get 10. So that's a possibility. Or 2 and 12. If I do 12 minus 2, I get 10. So it's going to be one of these. Okay, let's start with the 4 and the 6. The inner plus the outer have to equal the middle. The only way I can get negative 10 out of 4x and 6x is if I make them both negative, which would mean both of these would be negative. Now, will that give me a positive 24 somehow? Well, yes, because the negative 4 times the negative 6 is positive 24, which means this is the correct choice. All right, number 7, another super easy problem. X squared is x times x. 22 is either going to be 2 times 11 or 1 times 22. Okay, let's go with the 2 times 11 option. Inner, I've got 2x. Outer, I've got 11x. I'm trying to get negative 13x. I can get negative 13 if both of these are negative. That means both of these are negative. Will that make positive 22? Yes, sir. Negative 2 times negative 11 is positive 22. So that's the answer for number 7. All right, I'm getting a little tired of all these easy problems. I want something more challenging already. All right, so we'll have to do x times x will make x squared. 25 is probably 5 times 5, right? Could be 1 times 25, but let's go with this. Inner, we have 5x. Outer, we have 5x. Together, we need it to make positive 10, all right? The inner plus the outer equals the middle. Well, that will happen if both of these are positive, which would make both of these positive. Does that give me a positive 25? Yes, sir. Positive times a positive is a positive. So this is the answer for number 8.